Way, if the UJ lecture bombs out or doesn't load properly, we'll have a oh, got a Mike's calling. Hello? Hi, Mike. Great. Are you logged into Blackboard? Are you on our Blackboard page? You see the left-hand column that's white with all it says announcements and syllabus and everything? Scroll down to UJ lectures. And I spelled it wrong. I spelled it Y-U-U-J-A. I need to fix that. You see that? It's like second or third.
Dave says he used the link from last week.
You can also use the announcement link from last week.
That's what I did. I just clicked on the...
Here's what I'm talking about. UJ lectures, and then there's a little pink bell up in the left right-hand corner, and you click on that, it'll take you to the link. First, you got to click on UJ lectures.
If you go into announcements, that link should still be there.
On the UJ lectures. Okay, here's a better way. Can you click on it? Can you click on announcements? Okay, on the Sims 160 Cyber Class launch at the bottom, there's a link to click on that'll take you to it. Click on that. Click on that. Click on the mcckc.uja.com meeting. Yeah, just left click on it. Left click on it, yep. Did it do anything for you? No. Did you go back to the Blackboard page? All right, let's try it another way. Go into, click on the UJ lecture. Did you left click on it? It's in the, you know, on the left side of the screen where it lists everything out, projects and everything. Okay, if you see that, yeah. On the left-hand side of the screen, you should see all the projects and everything. You see that? You know, this. Okay, scroll down to UJ lectures. It's almost at the very bottom. It's like 3 from the bottom. Y-U-U-J-A. You see that? Right when you open the Blackboard page, there should be.
Is it Sim 160?
It should say Sim 160 Advanced Lathe Operations on the left side, and there should be an announcement, and then it should say syllabus, pause, live tooling manual, where we launch all our textbooks and things from. Really? Okay, if you're seeing the Sim 160 Cyber Class launch announcement, At the very bottom of that, there's a Yuja Meetings link that you can click on. Click that right now. Left click. It should say use my computer's mic and speaker. Oh, you probably, does it say that? When it says that, just click on use my computer's mic and speaker. Or dial the into the, yeah, do that. Use my computer's mic and speaker. Just click on that. And then it should be able to enter meeting. Are you in? Teach. Well, I'm gonna have to get back to it here. You keep pedaling, keep trying, and then if for some reason you can't do it, we'll just have to get you the link or something. Okay, I gotta get back to class, so keep trying. All right, bye-bye. Okay, so we are going to start working on our program, which is going
Your
to
video's
be,
down, by the way.
what?
Your video's down.
It is. Okay,
Yep.
hold on. Can you see the screen?
When you see the screen,
What do you mean my video's down?
like your camera.
You can't see me?
No, I can't see you.
Well, that's
I
not
don't
all
see you
bad,
this.
is it?
Well, I'm just providing you with information.
Okay. Well, I'm not going to. I mean, you guys don't really need to see me so much as we need to keep going with the class. So
Yeah.
I'll worry about that later. It probably booted me out when I was trying to get Michael on. So, all right, I'm gonna go back in here and load up our drawing so we can get moving. Okay, so everybody can hear me and you're seeing my screen. Is this correct? Okay.
I can hear you and I can see your screen.
Okay, thanks. Looks like one person, hopefully that's Michael. No, that's Dave. We lost Dave.
Dave, are you still in here?
All right, we're just going to get into the meat and potatoes of this and get the program written. All right, YC project. We got the PDF. Hopefully you guys were able to maybe download the Mastercam Home Learning Edition if you can. If you have a computer to do that. It's not obviously a requirement, but it would allow you to download models and things, and that way you can look at them and maybe take some measurements if there's something I forgot, or you can always email me. I can get you the measurements. I think most everything's there. So we'll just get started here. First thing we always do is put a safe start line in our program, but first we need a % sign. Turn on my cats. And program name, which is letter O. We can make it anything we want at this point. Main thing you want to do is not overwrite your other programs. So I'm just going to make this 98765. And we're going to call this YC.
Why
The reason
see?
I called it YC because it could theoretically be a YC question mark. Because on a lathe that has fourth axis capabilities, you will be looking at a part and you'll say, well, sometimes I want to use the y-axis and sometimes I want to use the z-axis. Why would I want to use the y-axis and why would I want to use the z-axis? So we call it YC question mark. So it's kind of a
Okay.
pet name for the project. One thing I want to do is kind of review. Let me check my thing here. Review the axis movement before we get started on the y-axis lathe, because it gets really confusing when we start programming, because you start getting X and Y mixed up. There's a good picture towards the end of the book here that, let's see if Michael made it. Ethan made it. That kind of illustrates the axis movement of the machine, and sometimes it can be helpful to have this up while we are writing our programs right here. So most of us are familiar with the X movement. By the way, this is a slant bed CNC lathe, and the reason it's a slant bed is because the X bed is slanted compared to like a manual lathe that has a cross slide, and it runs pretty much perpendicular in X and Z. So it's a flatbed lathe. The reason we make a slant bed lathe, and I know I've said this before, is for one thing, it makes a smaller footprint in the shop. You can fit more lathes in your machine shop because the X movement is put on an angle. Another good reason for this is because all the chips fall down off the guard that way, and they'll fall into the trap of the machine where they'll come out chip conveyor. So X and Z movement is pretty much what you're used to when you think about turning is what you deal with. With the additional axis movement, you have a y-axis as well as a c-axis. And with C, we've kind of experimented with C a little bit, but we're limited with C-axis movement because everything has to be done on center. And the benefit of the y-axis is it allows you to manufacture features on a part that aren't on center. For example, these 4 holes on this part are not on center, on the center of the part. So we look at this and we say, well, we're going to have to use our y-axis to drill these 4 holes, right? Whereas these holes, let's see, I think we'll have to look at the drawing, because unless we go turn on the wireframe and go top, so all these holes are off center. Remember, we have another project, which is the YC project, that we'll do here in a few weeks, that the holes are coming in at an angle this way, meaning that they are on center. So all these holes and this flat and these pockets, this pocket will all have to be made with the y-axis. Whereas this little side contour here, go back to shaded, Alt-S, the side contour can be done with the C-axis because we feed in on center and then just rotate it around with C and out with Y or Z. Already confusing myself, and it's only 8:22 in the morning.
Right.
A lot of times I would go in and with a chamfer mill and do these fancy chamfers, but we'll probably not do that. mostly because of time. But we will put the chamfer on the front here because that's a pretty easy enough thing to do. So let's see here. Turn my master cam on. Turn that down. Okay, so another good reason to have our book open is to get nice examples of what our program is, or the programming examples. And what you run into is with these live tooling machines is they have codes and certain protocols that are really specific to their machine tool builder. So, for example, we got a G195 here, and I think G195. Yeah, I'll probably set up a practice session with Michael today later on and get him logged in. He'll just have to watch the recording or something. So I'm going to pull out, well, you don't have my camera, my live tooling code. It's got my M codes, and it's got all my cross and face cycles, which is also in this book on page 12. Right here, basically is what I'm looking at. Page 12 and 9 is pretty much going to be your cheat sheet for your M and G codes. I like page 12 a lot because it gives you all your, your plane selections are right here. Your G195 or M196 is radial rigid tap. So you get all these high numbered G codes, and I wouldn't let that intimidate you. It's just another, like G195 and 196 are not going to work for an Akuma lathe, so, or a Mori for that matter. So live tooling is really super specific to the machine that you're working on. And for that reason, we don't really do a midterm where you have to memorize all your codes and things. By the way, Dave, you spelled teach wrong. It's T-E-A-C-H. Just kidding. All right. So back to our part. First thing we're going to do.
I'm not even sure he's in here.
Yeah, I think he's. If I hover over him, he's doing the spinny thing right now.
Yeah.
So we got Ethan, Chris, Dave, Sam, Blake, and you, Robert. So most of the time when you're using a live tooling lathe, you're going to want to get all your turning operations out of the way first. And like a couple of you guys on your C-axis programming project would use the live tooling holder to drill a 1/2-inch hole in the middle. And that's not really the best way to do it. You want to do any kind of functions that you can possibly do with the turning, because the problem with live tooling is a lot of time it doesn't have a whole lot of horsepower. You don't have a lot of rigidity, and you will always have your best finishes and things, and also you'll be able to remove material much more quickly using the turning functions of the lathe rather than the live tooling. So with that said, I want to go back into this Haas programming workbook, which is the turning workbook. I wouldn't say the old workbook, but it's the one we had from lathe class, and just refresh the G71 turning, because this is going to be something that's going to be on your final. And I'll be honest with you, it's one of the harder finals that I have as far as a programming project. So we'll spend a good amount of time reviewing this code so that you'll be ready for that. And hopefully, if you get to where you get to work on a CNC lathe with live tooling capabilities, you'll have a running start at knowing how to program it. So Control F, look for G71. Now, I would say that you wouldn't necessarily have to use a G71 cycle here, because we're just really not taking that much material off. And I always like to review the G71 cycle because it's kind of the cornerstone of turning on the CNC lathe. Auto chamfering, nope. One good refresher is that you cannot use automatic chamfering and radiusing with G71. It won't work. It'll give you a non-monotonous code error. Where are you? Here we go. Just going to use this example. This is like the gold standard example for a G71 turning cycle. We're starting, making sure we're at home. We're turning our tool on. We give it a G50 to set our RPM limits. Turn on the spindle with an M3. We are rapiding to position. Turning on our constant surface feet. And for some reason they feed to Z.005. I would just go straight to 0. The book does weird things sometimes for no particular reason, but it's a good reminder that there's no hard, fast rules. You know, I mean, people have different programming styles. I suppose at the end of the day, what's the right way is the way that produces the part quickest with the least amount of scrap. Or the right way is the way your boss wants it done. So I would always defer to that. So that said, first thing that you'll be responsible for here, and I'll just put a little right-handed caret here for where you're going to insert safe start line. You can get that from one of our other programs, or just think about what does the machine need to be in, what codes do you have to give the machine for it to be in default mode when you power it up. You want it to be in rapid, you want it to be in absolute, which don't do that because the lathe doesn't like G90. I was standing there scratching my head for about 20 minutes one day trying to figure out why the thing was giving me a multiple code error, and then it dawned on me that there was a G90 in the same startup line. With lathes, you don't use G90 and G91 like the mills. You use U and W for X and Z. And if you're going to do an incremental move in Y, it's V. So U, V, W, X, Y, Z. And then incremental for C is H. So no G90 or G91. You'd want to turn off your nose compensation with a G40. So see what you guys come up with for your safe start lines. These programs that you're just kind of filling in the blanks on are all also the same kind of principle that I like to have, as far as if for some reason there's something wrong. What's great about emailing them to me is that I can make little comments off to the side here, and then you can repair those parts of your program and resubmit it and get your full credit back. So, all right, safe start line. This would include making sure the tool's at home, although we can probably put that down here, G28. And that will ensure that before we call this first tool up, that it will ensure that the tool is far away from the spindle. All right, so anytime you're writing a program, like if I give you a programming assignment, or like your the final that's coming up here in a few weeks, it's going to be open book, so you can come to these program examples and literally just cut and paste, copy and paste onto your screen here, and just change the geometry. And the geometry is as simple as, think of an Etch-a-Sketch. You are picking the exact points. Each one of these moves has a point where it starts and stops. So you're going to be just picking those points of where it starts and stops. From Z0 is always the face of the part, and then X is always the center of the part. And any movement in X is going to be on the diameter, which is confounding, I know, because if you want to cut a perfect 45-degree angle, say 100 thousandths, you have to move it 200 in X and 100 in Z. All right. So following this example, we want to give it a G50. I don't use line numbers, mostly because, except for like on my G71 line. And the reason for that is I don't have to be thinking about what those numbers are as much if I don't have any other numbers to worry about. So I will make my P and Q like 1 and 2 because I don't have any other line number 1 and 2. So G50, that's 3,000. No M. I guess Mike never did figure out how to get on. Yeah, I'm gonna have to have some one-on-one time with him maybe this afternoon. I'll text him and we'll set up a fake meeting. All right, there's a safe start line. I'll come down here. Some of this is review, but for some of you guys, this is kind of your first day back after a very long spring break. Very long spring break.
Now this program, you're gonna post that on Blackboard, right?
Yes.
This one that you're writing.
I will after class. I'm going to post it on Blackboard under week, so you'll click on weekly homework, and then this will be there. And I'll save it as YC homework or something like that. There will only be one in there so far, so this will be the first one. And also, I remember last week I said I was going to post a computer recorded video of this because sometimes it's a little easier to watch because the Yuja kind of stalls out and has kind of some erratic movements and things sometimes, but I couldn't post it because it was too long. And then I tried to put it on YouTube, and YouTube wouldn't even take it. So I'm going to try to turn my camera off every 20 minutes or so. In fact,